What we have here is a component from BE Aerospace. What we want to do is inspect this part. We have a couple features we like to inspect, but we want to first start by measuring the part to locate it in the arm's coordinate space. We'll do that by measuring a plane and two lines. So here you can see the software is going to drive me as to where to measure and how to measure. So as I contact the part, I'll simply trigger and it's going to drive me to the next location. So we're completing our plane. Finish that, and now it's asking us to measure the next feature, which would be our line, the front edge. This is defining our X direction. This would be defining our X and Y origin. So now we're located, the part is located in the arm's coordinate space. We can begin with our inspection. The first thing we wanted to do is find the location and position of this, or size and position of this hole. Software is guiding us to that position. Make our selections. And now we have the information. The CAD model is sending us the nominal information for that size and position.
Okay.
That's the benefit of the CAD. We'll measure a couple more similar features. Now we have an interesting feature because we have tapped holes in this part. Can't measure a tapped hole with a manual device. What we have in PC-DMIS is the capability to use a single point click. And so this will give us an accurate position for these locations. So we'll run through these four. We can easily jump back to a normal circle, which is probed with multiple hits.
Okay, now explain this a little bit about the tapped holes again. This is because the probe is fitting right over the hole, is that correct?
Right.
Okay.
To do this, you do need a probe that's larger than the feature
Okay.
you're measuring into.
Gotcha. And then, but it knows that you're actually centering it over a hole and making that type of a measurement as opposed to taking multiple points?
Right. This function also works other than in tapped holes. So if you have a part with a lot of holes, you really want to get size and location, you can position the probe into that socket. It takes the plane, slices this ball, and gives us a diameter.
Okay, got it.
Here's the power of PC-DMIS. We actually have a prompt that comes up to ask us if we want to scan. Maybe we might measure some of these other features before this process has even been machined into the part. So a prompt has come up, do you want to scan? The integration of the ARM into the software has really improved since Hexagon purchased Romer. I can answer a yes/no question right from the ARM. So I'm going to click yes, and now we're going to begin that scan. With the scan, I'm going to drag the probe along the part, collecting a sequential series of points.
Okay.
So you can see all you have to do is hold the button and stay in contact with the part.
How quickly can you move?
You can move rather quickly.
Okay.
The device cycles at 1,000 hertz, so we can get data very quickly.
Okay.
We'll complete that. Now, what we're looking at here is the results of that scan. We have the blue lines are our tolerance band, and the green dots show where we have collected points. If we zoom in, you can actually see a small deviation arrow. It's showing that the material is, too much material has been removed.
See it.
The next thing we want to look at is our report. And that's, after all, the purpose for measuring the part. You want to get information out to your customer. So here's a sample report of CAD, and if we look, we're looking at this particular hole up on the left-hand corner. We see how much deviation we had. Because we had that CAD model, it's to the nominal. So we can see an error of 4 thou in position in the X direction for this feature, and the bar graph shows us a percentage of tolerance. If we look at a glance at this part, you see all green and yellow, we know the part's in tolerance. It's a really quick and easy way to get a lot of data out. After all, a picture's worth 1,000 words.
Right, and I think you said if it was out of tolerance, you'd see red instead of the green or the yellow.
That's correct.
Okay. Do I need CAD data to use PC-DMIS?
No, Dirk, you certainly do not. The CAD data does offer us the ability to bring the nominals in automatically, so it is a little easier to use and more friendly. It's less typing, less opportunity for error.
I'm not sure you touched on applications, but what about reverse engineering?
Certainly. With PC-DMIS, everything that I had measured, all those circles, and even that scan can be exported out as IGES data. You can then send it to your CAD system and do a 2D model or blueprint or even a 3D solid model.